What if we built an aircraft carrier that could hide underwater? The idea was simple, but the stakes were enormous. In the Cold War, the United States and the Soviet Union lived under the constant threat of nuclear war. Whoever struck first could decide the outcome in minutes. Surprise mattered, but survivability mattered even more. If Soviet bombers launched, American interceptors would have to reach them almost immediately, or millions would die. And if the United States decided to strike first, it would need to do so decisively before the enemy could respond. An aircraft carrier off the coast of the USSR would be incredibly powerful, but it would also be a sitting duck. And you know what isn't a sitting duck? Submarines. So why not take the carrier underwater? But here's the part that most people miss. The idea of a submarine aircraft carrier didn't start with a submarine, it started with a missile. If you look at the Greyback-class boats, the strange part isn't the weapon that they launched. It's the fact that the missile hangar is basically an aircraft hangar. A terrifying idea followed. What if the submarine wasn't carrying missiles? What if it was carrying fighter jets? But that's when the real problem appeared. Which aircraft? Because if this idea failed at the aircraft level, the entire concept would die instantly. So, to begin, in 1957, the Navy turned to two companies, Boeing and Douglas, and asked them to design something that had never existed before.
Douglas was first with the Model 640. It would be a single-seat small attack jet, and it would be folded up completely to sit inside the Regulus cruise missile bay, flexible enough to be carried by a submarine, or if needed, on a surface ship. It had a pretty conventional design and wouldn't look out of place from other planes in the mid-50s, although it would have some unique features for takeoff and landing. It would require a catapult system, like on an aircraft carrier, to get it into the sky. This was fine for an aircraft carrier, as many already had one on board, but building a catapult system into a submarine was much more complex, something that detracted from the proposal. The plane also featured a rounded underside and twin-shoulder jet inlets at a high relative position, allowing it to land on the ocean on a hydroski landing gear after the mission was complete, to be recovered by the vessel. For weapons, the plane carried a pretty large atomic payload, allowing it to drop atomic weapons on an enemy's coastal city. Although, as the bomb was fully exposed, the plane couldn't exactly land with the weapon undeployed. And as Scott Lowther said from Aerospace Projects Review, it would be suicidal. Douglas was unsuccessful with the concept, although it did take many design notes and then use them in the development of the A4 Skyhawk, so don't feel too bad for them. As for Boeing, well, they were really in love with a concept called the Magic Carpet.
Before we get into why the US military probably should be building a submarine aircraft carrier, let's talk about something that actually exists and actually works. Because launching such a big project for the US military is probably about the same as launching an e-commerce business. If you overcomplicate it, it never leaves the drawing board. That's why you need to use Odoo. Odoo is an all-in-one business management platform that lets you launch a fully functional e-commerce store in minutes, not months. Your guided configurator walks you through setup, and then Odoo's built-in AI generates your site structure automatically, and you just drag, drop, and customize. Adding products is also just as fast. Name it, price it, upload images, and done. And with Odoo 19, things get even better. There are several quality of life features, like customers can now preview product colorways instantly without clicking, improved shop filters to sort through your products, which are generated automatically, and you can use the new AI Sidekick to optimize your website's SEO for you with just one click of the button. And the best part is Odoo's e-commerce application falls under Odoo's one app free for life offer with unlimited hosting and unlimited support, plus a 1-year free domain name. So you can have a store and start selling right now for free. Like, that's ludicrous. And when you're ready to upgrade, you can actually access over 70 powerful applications, such as CRM, sales, invoicing, projects, and much more from just $24.90 US or 34.40 AUD per user per month. So if Odoo can make launching an online store this efficient, maybe the Pentagon should take notes.
Boeing's design was actually more interesting. It would take the existing Grumman F-11F and attach it to what was called a flying carpet. This was a rocket sled that could launch the plane vertical before detaching, and then return back to the submarine to be used again. It would vertically hover down like the rockets we see today at SpaceX, and then be recovered without touching the water. Although presumably it could float if anything did go wrong. The plane itself, the modified F-11F, would be able to fold up completely to fit inside the Regulus canisters and require extensive redesign in order to land back at the submarine. According to the research, the idea was that the plane would land vertically using jet thrust, and then a vertical rack would somehow grab it in mid-air. There was one other idea proposed, and it came from Convair. At the same time of this research, Convair was working on the only jet-powered seaplane fighter ever made for the US Navy, called the F-2Y Sea Dart. Clearly, a plane that could take off, fly above, and land in the sea was infinitely more simple and flexible than the crazy Douglas catapult or the Boeing rocket plane. The Sea Dart could fly at Mach 1.25 and to a range of 826 kilometers or 446 nautical miles. However, these Convair jet seaplanes, which by the way clearly deserve their own video, were too big to fit on the greyback and would need their own submarine, something that the US Navy had up their sleeve. This submarine design was originally created by the US Navy's Bureau of Ships and would be 460 feet long and be powered by a large nuclear reactor, like every other idea from the 1950s. It would be able to carry 3 modified Sea Dart fighters for missions and would have folding wings to fit on board. They would be kept in a round hangar within the hull of the submarine near the top, and the idea was that the submarine would surface, an elevator would take the plane to the top deck, and if conditions allowed, the plane would take off on the ocean. If the submarine encountered rough seas, then there was an alternative launch method of using a 170-foot or 51-meter track on the top deck. Once the mission was complete, the plane would land back on the sea and presumably be loaded back on board. It is unknown what happened with this design, but clearly the concept was well thought out, although we can see 2 problems. One, the weakness of the elevator hole on the submarine would prevent it going very deep, and the submarine would have a high center of gravity in order for the elevator and the onboard track to work for the plane. But the real cause of failure came from the Sea Dart. It was cancelled for poor performance and in favour for a supersonic carrier jet. For all intents and purposes, the idea of an aircraft carrier submarine was dead in the water, pun intended. While the aircraft research had resulted in a bit of a stumbling block, Boeing had not given up on the idea, and by the late 1950s proceeded to come up with 2 submarine ideas to complement a new jet design. And believe me, these were even more crazy. Not satisfied with just substantially modifying the F-11F, Boeing came up with a new jet design and paired it with new submarines. Beginning with the plane, it would have an impressive performance as it wouldn't need to take off from a runway, thus no high thrust to weight ratio. The wings would also be smaller, and this is kind of a scary idea, there wouldn't be any need for a landing gear. It would be essentially a manned missile. It would also have a speed over Mach 3 and be able to carry most modern missiles at the time internally. They also developed 2 versions of a submarine aircraft carrier called the AN-1 and the AN-2. The AN-1 would be able to carry 8 aircraft in 2 large hangars in the front part of the submarine. Each aircraft would have its own launch bay where the planes would be simultaneously prepared and loaded. The submarine would take around 5.5 minutes to launch 4 of the planes from surfacing, or 8 aircraft in only 7.5 minutes, a huge difference from the original designs that would take hours to do so. These planes would rise out of the submarine hangars and be prepared to launch vertically. They would rotate on the deck and would be able to launch at the same time, a big difference from the organized chaos of an aircraft carrier deck. The jets would take off vertically using the same flying carpet system. On launch, the submarine would recover first the flying carpets and then the planes once they returned using a series of cranes. This concept would recover the planes all at the same time and then vanish beneath the waves. The submarine itself would have 4 torpedo tubes at the front and the rear, forward and aft respectively, allowing it to still perform some of the traditional submarine roles. Although, thanks to the space taken up by the hangars, we can't imagine that there was a lot of room for armament. There would be enough ammo, fuel, and spare parts on board for these jets that they would be able to fly 160 sorties in total, or around 20 missions per plane. These missions would include bomber interception, anti-ship duty, and even nuclear strikes. It is unlikely that they would be used for conventional fighter interception or air-to-air combat due to the extreme speed of the aircraft. To land, these planes wouldn't exactly hover using the jet exhaust, but would rather belly up and stall right next to the vertical rack. It would then somehow capture the plane that would be moving quite slow. While complex sounding, this method of landing was much easier to perform by a pilot than landing horizontally on a pitching aircraft carrier deck, or worse, landing directly on the tail like some of the tail-sitter aircraft that were proposed in the same era. In stormy conditions, the submarine would only really be able to launch from the center platforms, as this would reduce the absolute motion of the pitching and make it much easier for pilots. An alternative design of the AN-1 also appeared where the jets did not rotate before launch, allowing for a lighter launch equipment and a quicker individual launch process. However, these systems didn't actually allow the planes to fly at the same time without hitting each other, and there was no way for the planes to be recovered simultaneously. We can imagine the chaos if the planes all tried the belly-up maneuver while looking at each other at the same time. Let's talk about the second option that Boeing engineers came up with, the AN-2. Be warned, this one's kinda silly. The AN-2 version of the submarine aircraft carrier had some pretty significant changes, and calling it the brother of the first design was pretty inaccurate. Gone were the 2 large hangars, and instead the planes were stored in their own vertical launch silos along the spine of the submarine. This verticality would mean that the submarine would need to be taller, causing shifts in the center of gravity. The advantage of this concept was that the simplification of the launch process. The submarine could surface, telescope out the fighter jet vertically, and launch the fighter jets just like future nuclear ICBMs. Once launched, the magic carpet would fall away and be recovered by the submarine very much the same way as with the AN-1. The pilot would of course have to board the plane vertically like the space shuttle and would need to hang there as the submarine surfaced. Recovery proved a harder beast to tackle. The problem was that not only would the aircraft have a smaller target to hit, but it would also have to be attached to the magic carpet during the landing as well. This doubling of components led to double the complexity. To fix it, the designers came up with a recovery apparatus that would be gyro-stabilized and be able to capture jets even in rough seas. But this impossible solution would also weigh down the submarine and move its center of gravity even higher. Boeing also considered that these designs would carry even better aircraft in the future, such as Mach 4 planes or even Mach 5 planes. The 2 hangars in the forward section might have also been merged to carry 2 or 3 even larger planes, such as bombers. Boeing lastly thought that this submarine could carry nuclear rockets, which you might realize is exactly what happened with future submarine designs. The AN-1 was considered to cost around $140 to $160 million in 1958 dollars, or 1.2 to 1.46 billion US today. And I think we all know that if it did go ahead, it would have cost substantially far more. But get this, we're not even done yet. Seeing Boeing pitch the AN-1 and AN-2 designs, General Electric thought that they would come up with their own take on the concept. Strap in, because it's about to get even bigger. General Electric, or as it was known back then, General Dynamics Electric Ships, saw a major flaw with all of these previous submarine aircraft carrier designs, that they were created for specialized aircraft. They realized, why develop specialized planes when a submarine could be so big that it could effectively allow anything to fly off it? That's right, GE wanted to turn a modern aircraft carrier into a submarine. It would need to be able to get as close as possible to the enemy coast, undetected, and then deploy a series of fighter squadrons. Thanks to the recent development of vertical takeoff and landing technology, or VTOL, aircraft like the Harrier jump jet could be deployed rising off the belly rather than on their tail. Despite this submarine would still need a big enough runway for horizontal rolling takeoffs to help conserve aircraft fuel. Many different concepts were studied by the team, and they include Design B, vertical silos like the Boeing AN-2, Design C, canted silos that would launch the aircraft at an angle, but like Design B, it limited the number of planes on board, Design D, twin elevated islands that would allow 2 vertical launch platforms for jets or helicopters, Design E, that had a full-length flight deck and 1 island in the middle, but like Design D, it was limited to only aircraft that could fly vertically. Design F had a plane ramp, no elevator, that planes could get to a huge flight deck. Take a deep breath because we're halfway there. Design G that liked ramps so much that it had one at the fore and aft, Design H that had 2 ramps in the middle of the deck, Design I that had an elevator in the middle of the ship with 2 separate hangars, Design J that had 8 different hangars and 1 giant elevator access, Design K that went nuts with the hangars with 16 of them and 3 well decks that could move, although I'm not entirely sure where the flight deck was here, and Design L, a mini submarine with 10 aircraft created at the request for the Navy for a cheaper solution. Estimated to cost only around $100 million in 1963 dollars, or $848 million today. And in the end, they came up with this, labeled Design A. This submarine would have a large cylinder with a flat deck on top that had a diameter of 55 feet or 16 meters. The sub would be 840 feet long at 256 meters and would have a speed of 20.8 knots. The flight deck itself on top would be 60 feet wide, which is 18 meters, and it would be 500 feet long or 152 meters, which is around long enough for some aircraft to make an emergency landing, but for comparison's sake, this is about half the length of the Nismet-class aircraft carrier. It would have 2 sails, and that's what these things are here, that would house several turbines that would provide electrical power, although the main source of electricity would presumably come from a large nuclear engine. The internal space would be taken up by a vast hangar. The hangar arrangement could be configured where needed and was able to carry up to 28 fighter jets in a high-dense configuration, with 2 more stored in the elevators for maximum capacity missions. The aircraft would be moved around the deck with a landing gear and taken up by either the front or aft elevators. These elevators would take the planes up to the outside deck through a double hatch airlock seal, as this would fix the problem found with the original Convair submarine we spoke about earlier and improve structural integrity. Speaking of structural integrity, the flight deck itself was 2 inches thick steel to serve the dual role of being strong enough for aircraft landings and also impenetrable to enemy fire. To ensure that there would be enough clearance between the deck and the actual water surface for safe aircraft takeoffs, known as the freeboard, the submarine would need to float unnaturally high. To do this, the engineers created vast ballast tanks that would fill with water when sunken and then filled with engine exhaust, presumably from the jet engines, to rise the flight deck above the waves. Compressed air was considered, like that used in other submarines, but it didn't actually provide enough lift to get the flight deck high enough. Underneath the hangar level, there would be crew facilities and a repair deck for aircraft maintenance. It would also have rocket air defenses, although the research seems to indicate that without support ships, it would mostly rely on its many aircraft for defense instead. In total, it would take up to 27 minutes for the submarine to launch its entire complement of 28 aircraft, and it would roster 430 crew and be able to go to a depth of 2,000 feet, around 600 meters below the surface of the sea. And I bet you're asking yourself, why stop at planes? This submarine could carry 2,000 men and their equipment, tanks, helicopters and more for a ground invasion force. It could even carry artillery that could be taken up onto the flight deck and then used for shore bombardment. In total, this flexible submarine would cost the US taxpayer $271 million in 1963 dollars, or $2.34 billion in today's money. The designers proposed that by the fourth submarine built, the cost would be less, but such a comment probably boggled the eyes of the generals when reviewing their work. Had it been built though, this aircraft carrier concept seems far more realistic than the Boeing AN-1 design. We can totally imagine that the vertical launching F-35C jets feeling right at home on board this cool idea. And who knows, maybe it really is out there below the waves. The concept of a submarine aircraft carrier, as in actual submarines designed for aircraft, went away in the late 60s. By then, the flaws of aircraft carriers had been overcome, and nearly any land-based aircraft could be converted to operate on these new giant nuclear-powered aircraft carriers. Plus, the objective changed for these ships from being a hidden target to a loud show of force. The US didn't want to hide an aircraft carrier's presence, they wanted the enemy to see it parked off the coast. But our story doesn't actually end here. Because you see, in 2005, Lockheed Martin was actually asked by DARPA to come up with a reusable drone aircraft that could be launched from Ohio-class submarines from the Trident missile launch tube. This multi-purpose UAV, called the Cormorant, would be constructed of titanium for deep water operations and would have a mission profile of either scouting, anti-ship roles, or even ground strikes. The aircraft would fold up neatly into the tube and be launched underwater at a depth of 150 feet or 45 meters. It would float up to the surface slowly before a rocket booster would ignite and send it up to a cruising altitude of 35,000 feet. It would then activate its turbojet for flight. For recovery, the aircraft would return to a preset location to meet the submarine. It would shut its engine down and seal its turbojet to deploy a parachute. It would then gently float to touch the water and sit there until the submarine arrived. On arrival to the location, the submarine, without surfacing, would send up a small robot that would find the aircraft using sonar and attach a small rope to it. The rope's other end would reel it back into the launch tube, dragging the whole plane back inside. Once the aircraft and robot were recovered, the tube would then be purged and the engineers could prepare the plane for its next mission. This whole study cost around $4.2 million, and Lockheed fully expected that they would win a second round of funding to build the first prototype. However, in 2007, DARPA declined to proceed with the project, and since then, the idea of a submarine carrying an aircraft has vanished beneath the waves. A submarine aircraft carrier has always been that missing link between Navy-based aircraft and submarine operations. There is that gap between something that can be launched undetected but still have the range and flexibility of an aircraft, especially over land far away from the sea. We could see that this concept could be used for special op missions where a team is sent from a submarine via a VTOL aircraft to a hot zone and return before the alarm can be raised. However, that now can be done with other tools, like from an aircraft carrier or an extreme long-range aircraft with mid-air refueling. Likewise, any strikes can be formed by a cruise missile, and nuclear capability has long since evolved away from plane-mounted atomic bombs. ICBMs fill that role and then some. Simply put, we have the technology to create a submarine aircraft carrier and have had it since the end of World War II. But there isn't really a need for it. Of course, there is also the possibility that the US government or others did actually go ahead with this plan, and right now sitting off the coast in those murky depths is something awe-inspiring. I'll let you decide in the comments. Today's video would have not been possible without all the incredible hard work of Scott Lawther and his aerospaceprojectsreview.com blog. The incredible amount of research and effort that he put into to find out all this information, the diagrams and the blueprints is truly impressive, and I stand on the shoulders of giants presenting this all to you today in video format. So I highly suggest that you click on the link down below to check out his website and see the many more incredible range of aerospace projects that never got built and were so close to changing the world of aviation forever. Trust me, it's a rabbit hole and you're gonna lose a whole afternoon discovering the undiscovered world. There was also a huge section of research that I skipped over that involved huge submarine battleships. If you want to see this as a video, then I suggest you let me know down in the description or leave a like and I'll get cracking onto this right away. And if you enjoyed this video today, then I suggest that you subscribe for more videos just like this one. So once again, this was a mammoth project, and I thank you so much for watching all the way here to the end, because at the end of the day, the viewer who is watching right now is the real hero of the story. So thanks again.